This tutorial introduces concentration calculations and the formulae required to solve questions such as what is the concentration of potassium hydroxide when 5.6 grams of potassium hydroxide is dissolved in water to make 200 centimeters cubed of solution. If you start with a bottle of water and then squeeze an orange into it, you'll form a dilute solution, orange juice. If you keep on adding oranges and squeezing oranges into it, it'll become more concentrated. We could say that concentration is equal to the number of oranges in a certain volume. We could also start adding some units, so we could measure units in decimeters cubed. 1 decimeter cubed is equal to 1 litre, and instead of oranges we could use moles. So here we have cubes which represent 1 decimeter cubed, 10 centimeters times 10 centimeters times 10 centimeters. So we have 2 blue cubes, so 2 decimeters cubed of liquid, and in total we can see 6 moles. So it has 6 moles per 2 decimeters cubed. A typical question might be, what is the concentration of a solution which has 6 moles per 2 decimeters cubed? We can say concentration is equal to the number of moles divided by volume. So 6 moles divided by 2 decimeters cubed gives us 3 moles per decimeter cubed. How many moles are present in 4 decimeters cubed of a 3 mole per decimeter cubed solution? So if we have 1 cube here with 3 moles per decimeter cubed, we need to take this volume and the 3 moles in it and multiply it by 4. So 1 decimeter cubed, 3 moles, 2 decimeters cubed, 6 moles, 3 decimeters cubed, 9 moles, 4 decimeters cubed, 12 moles. The number of moles is equal to the volume multiplied by concentration. We could also obtain this equation by taking the equation concentration is moles over volume and rearranging it. And we can rearrange it by multiplying both the left-hand side by volume, giving you concentration times volume. Moles over volume times volume. Volume will be on the top and also the bottom, so will cancel out, giving us just moles on the right-hand side. The final question type is, what volume of a 3 mole per decimeter cubed solution is required to obtain 9 moles? If we start off with 1 cube containing 3 moles, this is 3 moles per decimeter cubed. If we add an extra cube with 3 moles in, we can see here 2 decimeters cubed has 6 moles. If we add another cube with 3 moles per decimeter cubed in, we can see 3 decimeters cubed contains 9 moles. So what we're doing here is we're assuming the concentration remains the same and increasing the volume. So what we're doing is volume times concentration tells us the number of moles. So 1 decimeter cubed times concentration of 3 moles per decimeter cubed gives us 3 moles. What we can do with the equation, volume times concentration equals moles, is rearrange it. So we can say that volume will be equal to moles and divide both sides by concentration to give us volume is equal to moles over concentration. So 9 moles divided by 3, which is the concentration, tells us we will find 9 moles in 3 decimeters cubed. So we have our equation, moles is equal to concentration times volume. You could obviously write this down, or you may also want to remember it as a magic triangle. Firstly, we draw a triangle, and at the top we write the item which is on its own in the equation. Then, in the bottom 2 corners, it doesn't really matter which way round, we write the other 2 things which it is equal to, so concentration and volume. To use the magic triangle, you need to find out what you want, whether it's moles, concentration, or volume. You cover whatever you want with your finger. Then you have the equation you need. For example, if you wanted to work out how many moles were present in something, you would do concentration times volume. If you want to find out concentration, concentration is equal to moles divided by volume. And finally, if you wanted to find out volume, it would be moles divided by concentration. One final note, often volumes are given in centimeters cubed, so you will often need to convert volume in centimeters cubed to decimeters cubed by dividing by 1000. So your magic triangle would look like the following, with volume in decimeters cubed replaced by volume in centimeters cubed divided by 1000.